Okay, let's work our way through the back side of this review. I talked about number 7, I think, with all my classes, but we'll fill it in real quick. Here's a polynomial, and we're going to find degree, leading coefficient, constant, and our y-intercept. Remember, the degree is the highest exponent you have, no matter what order it's in. So highest exponent. Remember, the leading coefficient is the number in front of the highest exponent variable. So it doesn't have to be the first term. It can be the middle term. It can be the last term. You want to find your degree first. So let's look at number 7. The highest exponent I see is that 5. So that's my degree. My leading coefficient is the number in front of that 5, or that 5th degree variable. So negative 13. Constant is the number that has no variable attached. That's that 3. The y-intercept comes directly from the constant. However, it is a point and should be written as a point. I will take off on the test if you just write 3. You need to write 0, 3. Okay, so let's do the next. Highest degree, 4. Number in front of that, 23. Constant, negative 2. And y-intercept, 0, negative 2. Okay, if you've got this, you should do it on your own. Press pause and then check your work, okay? I'm going to keep going, but if you don't do it on your own, you're never going to get it. Just remember that. Highest degree, 3. Number in front. What is the number in front if there is no number? It is not 0. It is a 1. So the leading coefficient here is positive 1. Your constant is negative 6. And your y-intercept is 0, negative 6. Highest degree, 9. Number in front, 1. Constant, negative 3. Y-intercept, 0, negative 3. Describe the end behavior of each polynomial. Use correct notation. Okay, let me write the notation for you. As x goes towards negative infinity, f of x goes towards what? As x goes towards positive infinity, f of x goes towards what? This first one is on the left. The second one is on the right. Okay, so this means on the left, on left. And this one means on the right. We are going to plug in here either positive or negative infinity. So we're going to do positive infinity or negative infinity, depending on if our graph is going up or down. Okay, so here we go. In order to do end behavior, we look at our leading coefficient and our degree. So our leading coefficient, is it positive or is it negative? Our degree, is it odd or is it even? Our leading coefficient, well, first our degree is 5, so that's odd. And our leading coefficient is negative. If our leading coefficient is negative, that means it goes down on the right. Our degree is odd. Odd duck does something different, so it goes up. How would we write that in correct notation? As x goes towards negative infinity, which means on the left, f of x goes towards, well, it's going up, so it's going towards positive infinity. On the right, as x goes towards positive infinity, f of x goes towards negative infinity. Okay, leading coefficient and degree. Degree is 4, so it's even. E-V-E-N. Got to learn how to spell. Okay, leading coefficient is positive, so that means it goes up on the right. It's even, so it goes up on the left. As x goes towards negative infinity on the left, my graph, or f of x, is going towards positive infinity. As x goes towards positive infinity, f of x goes towards positive infinity as well. All right, here, leading coefficient and degree. Degree is odd. It's 3. Leading coefficient is positive. So I go right, up, left, down. All right, I'm not going to keep writing that. Well, maybe I should. Okay, as x goes towards negative infinity, f of x goes towards negative infinity as well. As x goes towards positive infinity, f of x goes towards positive infinity. All right, last one. Here we go. Degree, 9. So that's odd. Degree, odd. Leading coefficient, number in front of 9, positive. So the right side goes up, the left side goes down. So that should be the same. Is that true? Yep. Okay, I'm not going to write it again. Same as above. Same as number 13. Okay, let's look at number 15, 16, 17, and 18. Now, the directions are important. Make sure you read them. It'll tell you what to do. Create a polynomial that has the given zeros. So, step 1, turn the zeros into factors. Step 2, multiply it out. So, let's look at number 15. And let's see if I can get this here. Let's find my... So number 15, let's actually do it right here. Okay. So they give you the zeros, so they say x equals negative 2, and x equals 2/3, and x equals 1. And we're going to change those zeros into factors. Okay, so step 1, change them into factors. If you want to change something in a factor, you're basically moving everything to one side of the equal sign. So you end up with x plus 2 here. You end up with x minus 2/3 here. And you end up with x minus 1 here. So this is factor form and this is zero form or solution form. All right, next. This is ugly. And get it out of a fraction. The easiest way to get it out of a fraction is to multiply the whole thing by the denominator. So multiply the whole thing by 3. 3 times x is 3x. 3 times negative 2/3, the 3's cancel out, so it's minus 2. So now we have 3 factors, and we are going to multiply them together, 2 at a time. So let's start right here and multiply these guys together. X times 3x, 3x squared. X times negative 2 is negative 2x. 2 times 3x is plus 6x. 2 times negative 2 is negative 4. Let's clean that up. 3x squared, combine like terms, so plus 4x minus 4. Bring this guy down, x minus 1. Now we're going to multiply these together. Now when you multiply these, you're going to multiply this first term by everything. So 3x squared times x is 3x cubed. 3x squared times negative 1 is negative 3x squared. We're done with that. Let's move to the next one. 4x times x is plus 4x squared. 4x times negative 1 is negative 4x. I'm done with that one. Go to the last term. Negative 4 times x is negative 4x. Negative 4 times negative 1 is plus 4. Combine like terms. I have 1 cubed term, so 3x cubed. I have 2 squared terms, so negative 3 plus 4 is plus 1x squared. I have 2 x's, so negative 4 minus 4 is negative 8x. And plus 4. And this is my polynomial. Okay, let's look at number 16. So number 16 gives us some imaginary numbers. Ooh, this will be fun. Okay, remember with imaginary numbers, they occur in complex conjugates or conjugate pairs. So if they give you x equals negative 2i, then you automatically know that you have to have x equals positive 2i as well. If they give you x equals 3i, you automatically know that you have x equals negative 3i as well. Let's change these to factors. So now I have x plus 2i, and I have x minus 2i. Over here, I have x minus 3i and x plus 3i. When you are multiplying these together, make sure you multiply your conjugate pairs together, because things will cancel out and it is easier. I promise. Okay, so let's start here. And then we're going to do here separately. Okay, so over here, x times x is x squared. X times negative 2i is negative 2xi. 2i times x is plus 2xi. 2i times negative 2i is negative 4i squared. What does I squared equal? Negative 1. Don't forget that. Let's write that somewhere. I squared equals negative 1. So we never want to leave an I squared. We want to come in and exchange that with a negative 1. Okay, so let's clean this up. This cancels out, and we're left with x squared. Negative 4 times negative 1 is plus 4. Okay, let's come over here and do this guy over here. Same way. X times x, x squared. X times 3i is plus 3xi. Negative 3i times x is negative 3xi. Negative 3 times positive 3 is negative 9. I times I is I squared. Again, the I squared equals negative 1. So let's remember that. This cancels out. So we have x squared plus 9. Negative 1 times negative 9 is positive 9. And then we're going to multiply these two guys together right here. All right, last step. X squared times x squared is x to the 4th. X squared times 9 is plus 9x squared. 4 times x squared is plus 4x squared. And 4 times 9 is 36. Combine like terms, we end up with x to the 4th plus 13x squared plus 36. And that is our final answer, or our final polynomial.